Try again and see if this works. Come on, YouTube. Cool. Okay. So I don't understand what happened at all. I tried to go live and YouTube just said, no, you can't do that. But as I was saying before, I realized I spent like 5 minutes talking before noticing that YouTube did not let me go live. I actually don't know if it was YouTube. I don't know if it was YouTube or Restream or some other thing that rebuffed me. The machine did not allow me to go live on YouTube for whatever reason. But now I think we're good. So like I was saying, you know, I'm later than usual because I had some stuff going on today that kept me longer than I wanted it to keep me, but that's okay. It was for a good cause. But now that we're here, we can continue on with Odinmade Hero. We're going to kick off day 48 here shortly and resume where we left off yesterday on day 47, where, and now my phone's ringing. What else can happen? Oh, well, got to call that person back as soon as I'm done with the stream. Yeah, so on day 47, we were working on implementing better movement code for our little player here. And we're going to continue that with day 48. It looks like it's a shorter day, and so I think we'll finish this up today. But basically, we want to be able to glide along these walls, and that's what Casey was showing us how to do in Handmade Hero. So we're going to continue on with that today and just get one day closer to learning how to make a game. And the thing I was saying before I realized that I wasn't actually live on YouTube is that this eerie sensation of leaving one room and going into the next room and then seeing that it looks the same reminds me of PT, where you start off in this corridor and then you go around the corner and then you go through like the kitchen and you examine all the scary stuff, and then you come right back out into that same corridor. There's something about this that evokes that same feeling for me. It's not as unsettling because this forest is a lot happier looking than the corridor in PT, but just something interesting that I couldn't quite put my finger on before, but now I realize that's what this feels like. See, it's just the same over and over and over. When will it end? When will we turn and go? Yeah, there we go. Finally, something different. So anyway, let's go ahead and kick this off here and see what we learned today. Of course, Casey is muted for some reason. Why is that? In fact, I bet this is not going to show the right thing. Yeah. Got to fix my scene as usual. Because I was too hasty. I didn't fix it before the stream started. All right. Casey's good. I'm good. We're good. Except he's still muted, probably. Why is he muted? It's because the tab is muted. That's no good. There we go.
Start recording. Okay. Hello, everyone, and welcome to Handmade Hero, the show where we code an entire game from scratch using nothing but our bare fingers, never toes, no engines, no libraries, no nothing. It's from scratch here on Handmade Hero. That's the way we do it, and that is the way we have done it since day one. No reason to stop now. If you are one of those fine individuals who has pre-ordered the game on handmadehero.org, you can go to the link that you got in your email and download the source code anytime you want. That link keeps on working. It's the gift that keeps on giving, frankly. And so if you want to follow along with today's stream and you do not know how to do that and you're just like, what's going on here? It's really simple. All you got to do is extract the day 47 zip. This one, we're on 48. We're on day 48 right now. So extract that day 47 zip into a directory, and then also unzip the, if you want to use our the assets that come with it, that's a separate zip file you could download and unzip into the data directory. And that'll allow you to be like exactly where we are right now. So you can follow along with everything I do at home. It's kind of like one of those shows on PBS where, you know, the guy paints and you're supposed to paint along with him. And you have no idea like why he's, you know, what he's doing exactly, but then it turns out to be some kind of weird cherry tree at the end or something, right? And it's fine.
You know, it's weird that he says that because I actually just had this thought. It might have been yesterday or the day before, that doing programming on stream in this way, and the way that he's doing it, and the way that I think I'm also trying to go about doing it, but it's weird because I'm, you know, porting the code he's doing in C and C++ over to Odin. It reminds me of like Bob Ross doing a painting, and he's just going through the process of doing the thing. And I think the reason why that speaks to people is not just like the imagery that he evokes when he's doing his paintings, but it's also he's he's going through the process of doing the painting, and he's just doing the thing. You know, he's painting. He's actually painting. He's not just talking about painting, and he's not postulating, and he's not critiquing and doing all of this stuff that isn't actually doing the thing. And there's something about actually doing the thing that is just refreshing and humbling always. I'm always being humbled on stream, and I'm sure I'll be humbled again today. So let's go ahead and keep on humbling ourselves.
All right, so without further ado, let's get back to where we were yesterday, which was very deflating because I was just about to finish some code, and we had to end the stream because the stream was over. So let's take a look at what was going on there. If you remember, we had our little dude here, right? And we were about to do some collision work with him, and we wanted to be able to have him run into the walls properly. You can see he sticks on the walls right now, and so what we need to do is we need to fix that. We wanted to make a good collision thing so that we'd be kind of all set to go. All right, so how do we do that? Well, we started writing something. I was sort of teaching collision detection in baby steps, and so we were going down each individual baby step, and we got to the baby step of how to test against just simple walls. So just a point, like a moving point versus one horizontal or vertical wall. And we wrote the equations for that, and we solved them, and then we didn't quite get a chance to actually ever write the loop. So that's what we're doing today. All we got to do is write that loop, and then at least we can have some decent collision. Now, we've got other stuff that we want to do after that to make our collision detection a lot better, but that's the first thing that we need to do just as our baby step before we can really talk about what to do to make it better. So let's do that. Because right now, frankly, the collision in this engine is awful. Well, we don't really have an engine, but the collision in this app is awful. And it shouldn't be awful, it should be good. So here we go. What we have decided to do is take the place where the player was and the place where the player will be if he is unobstructed. So the 2 points, where he's going from, where he's going to. We have figured out all of the tiles that would be involved if we just made a rectangle using that span, basically. We're going to walk through each of those tiles, and if any of those tiles has a wall, like if it's marked as solid, then we are going to test against all 4 of the walls. We're then going to take whatever the soonest collision would be with one of those walls and keep that as the earliest collision point. That will tell us where our player will stop, if he's going to stop. Now, we pre-initialized the minimum intersection time, 1.0, which is basically all the way to the new position. 0 would be standing where we are. 1.0 would be all the way to the new location, right? We've pre-initialized it to 1.0 so that every time through the loop, when we check to see whether we've gotten a better collision than what we had before, if it's ever above 1.0, meaning it would be past where we would actually want to end if the guy could move all the way to where we want it to be, we just won't even consider it. So that kind of already takes care of all the collision stuff that would be past the place where we would end. Because obviously we don't care about collisions that happen after we get to where we were already going. And again, we'll still, our solution, when we do our solves, we'll still get those things that are off there because we're figuring out the time, we're doing a solve for the time at which you would collide, and that time is not bounded by anything. So it could say, oh, in 10 minutes, you'll end up down and hitting this wall. And it's like, well, great, thanks, but we're not gonna, we're not trying to take a 10-minute time step. So that's how those things get eliminated, is by setting this team into 1.0, which is the full motion that can happen. All right, so what we do here is we first start out by saying we're going to do each individual collision detection from the perspective of the tile that we are checking. So we take the tile that we're checking and we subtract away the player position, right, from that tile. So we can actually do it in one of 2 ways. We can do it where we have the player is we can have the vector going from where the player is. How should I say this? We can have where the player is be relative to the tile, or we can have the tile be relative to the player. And I think what we want to do here in this case is just make it so that the player is relative to the tile. So we're taking the tile center, and we're talking about the position of the player relative to the tile center. So basically, the relative thing for that is going to be, we'd want to do it this way. We'd want to subtract the tile position, right? We'd want to subtract the tile position from the player position, which would give us a vector from the center of the tile out to where the player is, okay? We then also have this, the player delta vector, which is pointing in the direction of travel. And that player delta vector is exactly as long as the total distance we want to travel to check. Basically, the entire move we would do this time step if we weren't obstructed. So we go ahead and say, okay, we get that relative new player P, that's relative to the center of the tile. And now we have the locations of the walls relative to the center of the tile as well, min corner, max corner, right? So now what we need to do is test all 4 walls and take whatever the minimum z is. So let's just test one wall for starters, right? And I guess I've already kind of started with that here, right? I said test wall, and I was going to pass the various parameters for it. So what I need to do is I need to write a function that'll basically update this for each wall so that we can test the 4 different walls of a tile. So I'm going to write it in place first for one wall, and then I'll pull it out into a function we can call once for each wall so that we don't have to type the same code 4 times, right? Assuming that I can. We'll see, maybe it's too hard to pull out and we'll make a macro. Who knows? We'll see. Okay, this should be minimum t. I don't know where z came from there. Okay, so here was our equation. Our t result, meaning the t along that, the percentage along the player delta vector that we would have to go to intersect a particular wall's x coordinate at an x coordinate. So a wall at an x coordinate, remember, is a vertical wall, right? So at the x coordinate of the wall we care about, right, we want to subtract whatever the player's x coordinate is, and then we want to divide by whatever the delta x coordinate is, so the x offset. That will give us the t at which we would arrive there. We then want to check the bounds of that thing. And in order to check the bounds of that thing, we then have to figure out where the other component would be, right? So where would the y be, right? Well, we know where the y would be. The y is just going to be that t result, whatever that t result is, however far the t result was, right? It's just going to be that times that player delta vector y, right? Because remember, I can do an entire vector, t result times the vector equals how far along that vector I've gone. And in this case, I only care about the y, so I'm just going to use the y component of it and save myself the trouble, right? It's going to be that. That's how far he would move along that t. And we've got the new player's x coordinate here. I'm sorry, new player's y coordinate here, right? So we can go ahead and let's do that. So we can go ahead and add that, and this is how far he would have gotten total, right? The new y coordinate is going to be his old y coordinate. And what? You know what? Why is this new player p? That's not right at all. That should be old. We wanted where he started from. It's old player p. I don't know why this is. Why is that new? Who did that? Who snuck in here? I'm sure, obviously, it could not have been me. Somebody has been into the code base and put in the wrong variable. How dare they? Those people will be found and severely chastised.
Where's that owl of shame?
All right. So here we go. We solve for that t result. We find out what the new y is, and now we just need to see whether that y is within the bounds that would be valid for this wall, because the wall is not infinite; it's between two things. So we want to say basically that if that new y is greater than or equal to the min corners y, right, then it's definitely above the minimum bound, and if the y is less than or equal to the max corners y, then it's within that maximum bound of the tile. I don't know what this test wall is doing there. So if it's in there, then this is actually valid. And if it's valid, then what we want to do is check that t-min. So we want to say if t-min is greater than t-result, then that means this is a closer collision than we've had before, right? Excuse me. And you know what? We can check this first since it's a simpler test. If that t-min is greater than t-result, then that means that the t-result is a closer collision, and so we should accept it, right? So we should accept it, and well, sorry, we should accept it assuming that the wall exists at that point, right? So that's really all we need to do, but there's a catch, and I talked about it on the last stream. Don't know if you remember. What's missing here? Does anyone remember what's missing?
My useless test, or my useless stub test wall proc. Goodbye. All that effort that I took to paste that out 4 times. Let me just make sure that I'm keeping up here correctly. So I don't know where this wall X is going to come from, but it's going to be, our T result is going to be based off of the rel old, and I guess I hadn't updated the actual declaration of that. The relative old player position. The difference in X from where the wall is divided by the player delta, okay, along the X, and then this Y here is going to be the difference. He just said this, the difference along the T result times the player delta Y. And so if that y is greater than or equal to the min corner, what is this min corner again? It's actually down here. Okay, the min corner of the tile. Okay, if it's within the bounds in y of that tile, then we update t-min. Okay. I'm still a little bit fuzzy, but I think I'm just about on the same page. I'm on the same page. I just can't understand all the words on that page yet.
Remember what's missing. Remember.
Nope. He's I appreciate the confidence in this asking to remember. You can do it. You can remember. He's so certain with this expression here, and he's even doing a magic hand wave. But nope, I don't remember. That was 1 day ago. That's too many days ago.
Okay, I'm just going to assume that you remembered, and the stream is right now filled with people saying the thing that you are all remembering. When we do this computation for t result, right, we are going to get the intersection of essentially the whole line that the player is traveling along with that wall, which means he could go backwards and hit the wall, which we don't care about. So what we want to do is also say, well, t result has to be greater than 0 to begin with, right? If t result is not greater than 0 to begin with, then we're not gonna count this as a collision, because that means the guy had to go backwards in order to hit it, and we're not going backwards, so that doesn't count. So we're strictly interested in collisions between 0 and 1. That's where we want to be. And so
I think I get it. That would be after we'd already collided, which is basically what he just said, but it's like the difference between just reflecting us out and bouncing off and coming back towards, right? Because we don't want to bounce. We just want to hit the wall, not bounce, and then glide along it. I think that's why we need that.
So that's what we're checking for. So assuming that we got that, we will then stop. So which wall did we collide against here, right? Well, so if we took wall X to be, oops, it's not accidentally hit page up. If we were assuming that we were going to test against, let's say, our max corner X, right? So max corner X testing would basically give us, excuse me, got an itch. Would basically mean that we can test against the right wall of anything, right? So that's good. We could go test that afterwards. All right, so now we have one more thing. I don't know if when I said what's missing, you guys remembered this as well. So I'm just going to come out with it. We again harped on it yesterday. This guy right here. What's going on with this guy, right? What is the deal here, people? This might be small. It might be so small, in fact, it could be 0. And what would happen if we were to divide by a very small number or 0? We would get a disastrous result. 0, of course, would cause the FPU to actually put like an invalid value in there. Or if we divide by a very, very, very small number, this will end up being huge. That's not such a big deal because it'll immediately get thrashed by this. But basically, we got to make sure this guy isn't 0 at the very least, right? So we got to check to make sure that player X is not equal to 0, because if it's equal to 0, it's bad news bears. Now, fortunately, if I were the sort of person who ever remembered all the weird rules for like what happens when the SSE registers when you divide by 0, it's possible that this is one of those routines where it would just work, right? Because if you could guarantee that T result would always be greater than 1 in the case where this was 0, we'd actually be fine, right? Because this check would nullify it. But I don't know, right? So I'm not going to leave that to chance at the moment. And if we really care about it down the road when we're doing optimizations, we will go read the manual and figure out whether this is a safe divide by 0 zone where we could like turn off divide by 0 exception and just let stuff rock out. You know what I'm saying? Like one of those concerts where everyone gets backstage. You know the ones I'm talking about. Anyway, so basically, that is all we really need to do to test against one wall, modulo bugs that I may have coded in there while I was yakking. So in theory, we should be able to test against one wall now while we are moving around. So I guess we're only testing against this wall. And so, oh, you know what I just realized, though? We're going to have to actually enable this case, which we didn't yet. That's what we actually...
So we've got some type issues here, which is weird because I would have thought that tmin and tresult were the same type. I'm guessing tresult is an F32 because, yeah, if the rel player P is a vector 3, which I'm certain it is, then tresult must be resolving to be, yeah, and then same thing with this, right? Yeah. So that's definitely an F32. But tmin, yeah, that must be, well, what would be the Odin way to do this? Just cast that one. I think what I was doing in other places in the code was this. But that doesn't feel very Odin-esque for whatever reason. I've also seen it styled this way. Whatever. So I think that just fixes that. Yep. And then he was about to enable this. This new code that we've been working on to see if it works at all. So let's go ahead and see if it does the thing. And I can't move, so what's that about? What's that about?
There we go. Okay. So we got some compiler errors. X is not a member of tile map difference. That is actually true. So that's its rel. That's what I wanted, rel. I already made that into a v2. There we go. So now who knows what will happen now? Okay, so we're not in good shape. It's true. Oh, well, that's just because I forgot to actually move the dude. Sorry, dude. I forgot to actually move him in a case where, you know, because basically what happens here, right, is we set these sorts of things like whether you collided and that sort of stuff, right? And then we did some updating stuff here depending on the situation and all that sort of stuff. So what we got to do here, I don't even know what was this even supposed to be. If call p abs tile x is less than entity p abs tile x, r equals, and so then what do we do with the r? We just, okay, so this was our wall. This reset the velocity. So we're gonna have to do something similar to that with the velocity, but for right now we don't really care too much about that, so we'll do that in a second. But this is basically the problem that we need to solve right here. We need entity p equals new player p, and we haven't done that yet. So basically what we need to do is we need to actually make our new player p dot offset code. We want that to actually, yeah, we don't even want that to be happening the way that it's happening up here, really. This is all kind of not good. We're just gonna, you know what we're gonna do? This is what we're gonna do. We're gonna move all this cruft into here, and then we're going to say, all right, this is the actual stuff that we actually want. So we've got our player delta, that can be computed stably. And then what we want to do is say, okay, when we actually have the player delta...
Let me get caught up here first. So move this old new player P stuff down and out, right? Old player P is good. and player delta should stay in there. So this gets grouped together with this. And yeah, that goes together with that. And that just kind of walks on down there. Don't know why this code indented like that. It's weird. And I think that's right. Did this change at all? We square the dt, multiply it by 1/2 of the acceleration. Yeah. To calculate that player delta. That looks good. That all looks good. Cool.
We need to recompute the velocity still, which is this guy here, but we don't really know what's going to happen to that exactly. I guess we kind of do. We could do that. So it depends. We have to talk about the order of operations there a little later when we're finessing this, but that's mostly right. And so what we want to do now is actually move this stuff down there. So we've got our player delta, and we've got that stuff computed, but now in this case, what we're going to do is we're actually going to go ahead and do that update in a slightly different way. Instead of doing it the way we were doing it before, we're now going to multiply that delta vector by whatever our minimum intersection was. And so that way, if we hit something, we will only go as far as the thing we hit, because that tmin will have been set to whatever that closest thing we hit was in here. And if nothing gets hit, then we'll just use 1.0, which will step us all the way there, right? Which is what we wanted. So basically that's it. And then I can do the actual update move, which is here, and we'll just have to deal with velocity in a second once we're ready for that. Okay.
Make sure I am dropping this in the right block. Yeah. So that goes right in there. And what else did he do? Is that it? Yeah.
And we'll just have to deal with velocity in a second.
Not quite, because we have to actually update the entity's position. Okay.
Once we're ready for that. Okay. So we've got new player P, abstyle X being a complaint here. That's because this is all just, this is all, oh, okay, that's, all right. So never mind, I guess I did need new player P. I guess I did need new player P because I need to actually test against that abstyle X. I apologize, new player P. I guess I thought ahead more than I thought I was. Well, maybe I didn't. I could have just done that by accident. I don't actually know that past Casey was smarter than future Casey in this particular case. All right, so...
Well, both past and present Casey have a better understanding of what the hell is going on than I do. Yeah, because this needs to be like that. Otherwise, you can't get these values. So... Well, does he pull that out? Update the offset. Yeah, gets rid of it there. And then there we go. That seems good.
We've got new player P, and it's actually, there we go. It's actually being computed there, and now down here, I just have to basically redo this a different way, right? I just have to redo it to be the new way. All right, so at least it can still move, so we know that our tmin equals 1 when we don't hit anything is working. So let's see what happens when we go here. Perfect. That's actually exactly right. And we should be able to walk straight on through this wall, right? Yeah. That's hilarious. I can't get back in because there's walls on that side. Oh no, my guy is trapped in the wilderness. Help him. Oh, awful. All right.
Trapped in the wilderness, but it's the same wilderness that was inside of the room. It's no difference. What is the metaphor here? Oh, well, now we can't travel across planes, z-planes, I mean, and that is not working. Is it working? Something terrible has happened. My hero doesn't exist. Yeah, that's no good. What wall are we even testing here? I thought we were testing a wall along X. So I feel like I should hit one of these, but I'm hitting none. Is that the same thing that happened to him? Well, if I go this way, okay. Yeah, and then we can't, yeah, we can go back. So that's not good. Something here is busted.
redo this a different way.
So it updates the new player P. Oh, I didn't even use the T-min. Yeah. Duh. That was the whole point. We calculated it and then did nothing with it. In fact, is it even still in scope here? It is, right? Yeah. Okay. Maybe that fixes it. Yeah, maybe not, actually. Yeah, no. Because all that means is that should fix the gliding issue, which is the whole point of this change we're making. But it does not account for the fact that we're not hitting the wall at all. So what gives? We get our T result. And this rel old player P X is the same thing as his rel. Player delta X is right. Get the Y plus the T result times the player delta Y. And I guess I should... Oh, why did that happen? I never know whether to leave white space around the multiplication operator. I see Casey leaves no white space around the star operator and the divide operator, but around pluses and minuses he does add a space, which is kind of interesting. I don't know why, but I just prefer to use like the same thing uniformly, whether it's plus, minus, multiplier, divide. So T result is greater than or equal to 0. If T result is greater than or equal to 0 and T min is greater than T result, we then check the min and max corner Y and then update T min. Yeah, I mean, maybe that is all just correct. And he didn't actually delete all that test wall stuff. He actually commented it out. Thought he just zapped it out of there. But yeah, what gives? What gives? I should be hitting this wall on the left. And I should be hitting that wall on the left when I try and go back into the room. Right? So why don't I? What did I mess up here? The abs tile Z looks fine. T-min is 1. All of this, I mean, this code has always worked the same way, so nothing should be special or different about any of this. We haven't changed any of this. What the hell did I do? What on earth? This seems fine. It's a little weird, but we're just splatting the same value into both X and Y for the min and max corner. The subtract seems fine. I guess I could pull the relative X and Y out of this so that I'm not... Just so we're getting things as close to how Casey is doing them as possible. But I honestly don't understand why. Unless there's something else up here that I messed up. Yeah, I mean... I guess it should be in here. Something in here is wrong. Because this is the wall test code. And we're saying... that the max corner X coordinate is the wall X that we're going to work off of. Oh, man. No fun. Why is this happening? Well, maybe I'll just watch and the answer will reveal itself to me.
Right, I just have to redo it to be the new way. All right, so at least it can still move, so we know that our team in equals 1 when we don't hit anything is working. So let's see what happens when we go here. Perfect. That's actually exactly right. And we should be able to walk straight on through this wall, right? Yeah. That's hilarious. I can't get back in because there's walls on that side. Oh no, my guy is trapped in the wilderness. Help him. Oh, awful. All right, well, that was a mistake. I admit that. So that's exactly what we're supposed to do. Let me rerun it again because I want to show you one thing first, just so we were all clear on it. So you'll notice that he is able to interpenetrate the wall now, and that's because we're only checking his one base point, right? This is a point versus, well, it's a line, but it's the motion of a point versus a wall. So we're only checking that one point that's his sort of base point, right? So you can see that. So he interpenetrates. So one of the things that we're going to do is expand him to an area shape in a bit, so that we can collide against that. But for now, I just wanted to point out that that's why that's happening, just so everyone understood what's going on there. And like, don't do this. Don't ever do that. Do not walk out of there until we implement the other one or we're in trouble. We can do this with impunity probably, can we? No, we didn't. That didn't work very well either. That just I'm totally stuck now. Yeah. So we got to go ahead and fix all the rest of this stuff because we're bad news here if we don't put the rest of these walls in. We're going to have guys ending up stuck in things all over the place. All right. So all
Weird. I don't see at all why I don't get the same behavior as him. Oh, he doesn't do this. What? So maybe he... Well, this shouldn't matter, right? What the heck is going on there? This shouldn't matter. I think that was all he did is he pulled that out. Yeah, that should not matter. How could this happen? We were doing fine. We were keeping up just fine, and then... I did something dumb. I mean, this isn't any different. That's the same delta equation.
I apologize, new player P. I guess I thought ahead more than I thought I was. Well, maybe I didn't. I could have just done that by accident. I don't actually know that past Casey was smarter than I thought I was. I apologize, new player P.
Oh, he moved this code out too. So new player P. Well, where else are we even using that? Down here, yeah. Okay, that's gotta be it. I didn't catch that he moved this code back up as well. Of course, now this could all be out of order. So we get the old player position off of the current entity position that was passed in, and then we copy that into the new player position that we're going to start doing manipulations on. We get the player delta using our motion equation. We get the delta P out of our other motion equation, right? Get the position change, get the velocity change. Well, this is a little bit... Yeah, no, that's right. Because that's just going to store that right on the entity. But the offset of that new player position, we want to check that with the addition of the player delta. And then this, yeah, this right here, I think was all that was missing. But he kept that to do in.
I guess I thought ahead more than I thought I was. Well, maybe I didn't.
I don't know. This probably doesn't matter, but I'm just going to leave that where he left it. Okay. So now if I test this, I think we're good. let's see. Or maybe I'll be not good. Maybe I'll be bad. Because now I'm like stuck on something that isn't there. What the hell? How could this happen? Well, we're getting stuck. We're colliding now. It's just we're not colliding correctly. So that sucks.
Just on that because I need to actually test against that abs. This is all. Oh, okay. That's all right. So never mind. I guess I did need new player P. I guess I did need new player P because I need to actually test against that abs tile X. I apologize.
Damn it. Okay, yeah. So we get rid of... I left that up here as well. So the offset was wrong. And basically saying that we're... Yeah, that makes sense. Well, this is still wrong. Jeez. Welcome, said who. I'm good. And I am on day, what is this, 48 or 49? Day 48. Which is specifically line segment intersection collisions. And things were going okay, but then I just started getting stuck here. On nothing. Well, first of all, I wasn't colliding with anything. That's what we're trying to do. We're trying to get the movement collision to be a little bit more graceful, but it's anything but right now. I'm all sorts of screwed up. Did I save that change? Come on now. Let's make sure that we're running the code that we think we're running. Yeah. So why is this happening? So this makes sense. This is calculating the new player position offset based off of the T-min that we wanted after we do the search in T. And that seems totally reasonable to me, but we're clearly not doing the search in T correctly. And if I go back up here, well, this needs to change, right? This is gone, I think. I think this is another thing that I missed here. When he backs that code back out of the if zero, that must not be in there anymore. Well, I guess I can just try... Shoot, I don't even know. Because if we're calculating the new player positions offset off of the delta to then compare that to get out the T-min that we care about, then we do have to do this. I just can't see because he's yanking and throwing the code around so quick that I kind of have to... Yeah, this isn't even having an effect. Why would that not be any different? And then I can go up here. See, that makes no sense. Why am I able to go... off the reservation there? That's messed up, dude. We're not even doing anything crazy here. Well, he definitely pulled out the changes here at the top where we start doing the search and T calculation. This is all working off the old player position, or I guess the max between the new and the old, to figure out, yeah, the bounds that we want to start iterating over. None of that changed. Maybe I got this wrong. What is this test tile P? Yeah, no, that's right. We get the tile value out at that location. Oh. This was just done wrong. And that makes sense because it's like where you're stuck in X. Okay. Yep. Yeah, that was it. And I didn't catch that because we weren't bothering to look at old code. But we never verified that this old code was working either. But that makes sense because we want to know at the tile value on the next over, and we were only checking to the left. So if I undo this, okay, that's why I was fixating on the wrong thing. Helps to step through all of the code and actually see. So we're just stuck on one tile there, but we're only stuck on the X. I guess I don't know why we're able to move to the right, or why we're not able to move to the right. That's kind of strange, but we can't move left or right off of the tile that we start off on, but we can go up and down just fine because we don't have any checks for X. But again, I don't understand why we can't move to the right. That seems weird. Although maybe it doesn't, because the min corner and max corner are dependent on where the new and old player positions are relative, so well, actually no, because well, he's probably about to implement this for all four. I guess I shouldn't worry about this. I'm thinking too much about this. It probably doesn't matter. The point is that we figured it out, and I think we're finally where we need to be. Okay.
So all we really need to do now is turn this into something that tests all the walls. So I'm just going to pull this out.
Yeah, so Sedhu, thanks for joining, by the way. What we were expecting to see, right? And maybe you already came to this conclusion already, but what we were expecting to see is this right here. I want to hit this wall all the way on the left, right? But because that check was not checking to see if the tile was empty, it was asking if it was empty. Basically, we were colliding on an empty tile rather than a not empty tile. And that, like, once I realized that's what was going on, that just immediately made the what I was seeing make sense in my head, right? Because this is basically saying if the tile is empty, right, then you're not allowed to go there. So we were never able to step off the tile that we spawned on in the X direction. We could only move up and down in the Y because we're only checking in the X direction. But again, I would have thought it would have been only in the X direction, or on the left. But maybe, yeah, and that makes sense because we can't go off the left, we can go off the right side of the room. See, we're not colliding with the right wall yet, but we'll get there. Maybe it'll make sense to me in a little bit why we can't step off the tile on the X direction if that check is swapped to basically check for an empty tile versus a tile that's filled. Yeah, the logic was just inverted, that's all. But there's something else going on there where we're colliding with the right empty tile, but not with the right wall, which seems kind of like if it was actually like inverted 1-to-1, right? You would expect that I would be able to walk off the left. I wouldn't be able to walk off the left side of the tile, but I would be able to walk off the right. But I was seeing that I couldn't walk off of both, and I think that might have been why I didn't see this sooner, or intuit it sooner, I guess. Anyway, let's move on
into a function and see if I can just functionalize it, right? So I'm just going to go ahead and say, all right, I've got this guy here. It's going to be test wall. I'm going to call it. It's going to do this stuff, and we're going to see what we can do in terms of making this usable. So let's assume that I pass. Did I leave? I left it all in there, right? Yeah, good. So basically, we want to pass this the wall X, right? In this case, it could be an X or a Y.
That's sad. I deleted my test wall proc prematurely. Go back 3. Damn it, I knew it was 4. Indenting is so much fun. Alright, so we're going to make this generic, and test wall is probably going to return a bool, I guess. Oh, it's going to return nothing? Well, we'll see.
We want to pass the player delta X, right? And these are actually just going to be like wall, I guess wall X, player delta X, we'll do them like that. Player delta X. This will be the rel X, so we got to pass the rel X as well. And then we got that. And then we need the player delta Y as well. There we go. And notice we're not passing this as a vector. There's a very good reason for that. I'll put rel here first. The reason for that, of course, is because we don't actually know if these are X's and Y's. They could be inverted, because, well, you'll see in a second. Because we want to call it for both ways. We want to call it for Y intersections and X intersections, right? Okay, and so then I got my rel Y as well, right? Rel Y. Again, I don't know which sense those are. I got my T result, my T min. So then we got a T min is the thing we're updating. And then we got our min Y and our max Y, right? So we got our min Y and our max Y. Okay, and that'll do the wall test. So what is the problem here? T min music. There we go. So that can be updated. And so now I just need to call this, right?
So I guess he's going to modify the T min inside of here, which means I kind of want to change the order a little bit, so I don't have to write F32 in 2 different places. Max Y, F32, and then T min will be the only pointer. I guess that doesn't need to be split up so much. And oh, he pulled that out. Does that mean he's going to put it back in over here and then feed it to the proc? Was he already heading in that direction and I just missed it? We don't see. Oh, okay. Well, this is going to have to be calculated, but I don't know that he's going to declare it. He'll probably just pass in each of the 4 corners, right? To 4 different calls to test each wall. We will see. So this is the wall C, rel X, player delta X, player delta Y, rel Y, T min. Yep, we're gonna dereference that now, and then I suppose this is just gonna be min and max Y. We have to dereference this, and that looks about right.
Music. There we go. So that can be updated. And so now I just need to call this, right? I just need to call this with the same things I was calling it with before. So in this case, I call it with wall X, and that's going to be max corner X. There we go. I've got my rel X and my rel Y, and then I've got the player delta X and the player delta Y, right? And then I've got.
Kind of want to rename this to just rel, so it's not so verbose and then we don't have to split up this call. And now we can call it just like he's calling it. Rel Y. Split this up here. Player delta X and Y. And then we want min corner and max corner. And then tmin. Well, a reference to tmin. That seems right.
Got my tmin, and I've got my min corner Y and my max corner Y, right? And that is my test. There it is. Now what I can do is I can just spam this, right? I can spam this out and say, all right, let's test the other one. So now let's test the min corner X as well, right? And to do that, all I have to do really is change this, because it's the exact same test, it just gets a different coordinate. And then if I want to test the Y, right, all I have to do is pass that and flip the things that I was passing, right? I just flip them.
Yeah, this is a tough one because I don't know how else you would name these parameters to make it more generic. But just swapping them when you pass them in. Well, that's what you'd want to do anyways, but I don't know how else you would name this. It would be, instead of player delta X and Y, it would be like player delta plane of concern. Or axis of concern. Yeah. Not plane, because plane would be both X and Y. I think it'd be player delta axis that we care about, you know? So, and that's just way too much. Way too verbose. I think just looking at it, you can intuit what it is you want to do. So max corner Y, and then flip those, change that. And that becomes min corner Y, and then I'm jumping the gun, and of course, well, it doesn't return anything, so, and that makes sense because we're just updating the tmin in here. Now it'll work. So maybe I did something wrong here and my understanding is bad, but if not, we should not be able to leave this room that, even if we could leave, it wouldn't make a difference because it's the same room in the end. So it's a little bit off. Like we're colliding with the top of the whole room there. I don't know if that's what's going to happen on his end, but we do collide properly there with the bottom. And right and left look good. So I think we're good. Cool.
Because it can just basically do them in the opposite way that it was doing before. And that should test against all the walls of the thing, if I'm not mistaken. Could be mistaken. Who knows? We'll find out in a second. Won't we? So there we go. That hit that wall. That hit that wall. That hit that wall. Oh! I spoke too soon. We are missing.
Aha, he has the same bug as me. Sweet. Why is my chat messed up? I'm seeing comments in here that are not... Man, when I got logged out on OBS, that just screwed everything up. This comment is cut off, so I can't see all of it, but I do want to read it. And of course, OBS doesn't want to show it to me. Hold on. I see you. I see you in there. Let me see if I can pronounce this right. Necromity. Holy heck, hearing your voice is so nostalgic. Anyway, it seems like a nice stream to vibe in. I don't know too much about coding, but I know I should learn more about it for college. I've only done a little programming, but it was fun. Yeah, I really enjoy it. You know, I don't know if like it's becoming more of a common thing to do in curriculum, but it was basically, if it wasn't going to be your major, right? And I mean your major specifically if you're doing computer science. If it wasn't going to be, if you weren't going to major in computer science or at least minor in it, then you would, it would be considered like an elective, right? But if you were going to do some other engineering degree, it certainly wouldn't be mandatory. But I know like more and more it's becoming like a generic skill for everybody to learn. Like this analyst on my team who got laid off almost a year ago never really learned how to write SQL, but as part of the job hunting effort, last I heard, he was learning SQL, and he never had to do that to do his job well before, you know, but just to make himself more competitive in the job market, he took it upon himself to start learning that. So it seems like it's becoming more and more of like a thing that just like everybody needs to know just enough of to do very small, simple stuff. But, you know, for somebody like me who just has code on the brain all the time, it's like something that I'm always going after and trying to learn more of. So anyway, yeah, hope you enjoy the stream. Let's keep going.
Missing a wall. Which wall are we missing, people? So we're missing the y max wall. So there was a typo somewhere there. That would be max corner dot y, rel x, rel y, player delta x, player delta right, min corner x, max corner x at tmin. What did I type in wrong there? I made a mistake of some kind, but I don't know what it actually was. Well, you know, I actually don't necessarily know that I made a mistake yet, because technically there's something that we haven't quite done. It's a separate issue, but I guess I don't know for sure. Let's put it that way. So let me double check and make sure that that's not the case. What I'm going to do right here is just check to make sure that I don't have a thing where I'm just stepping through the wall, because we're not actually doing anything to prevent that at the moment. Yeah, so that's what I thought. All right, so that's fine. So let's talk about that. All right, so we've gotten to the place where we're successfully testing all the walls, but now we have to deal with problem number 2 for this kind of test, which is that when we actually do this computation, right? So here's the problem that we have. When we actually do this, we are finding the point where he exactly hits the wall, where this guy exactly hits the wall, right? And we have a problem, which is that if we then allow him to actually be there, on the next time step, he won't actually necessarily, you know, due to precision issues and so on, he won't necessarily ever hit this wall, because he might be just a little bit to the other side of it, right? Because we're counting on that equation producing a t that is greater than or equal to 0, right? But if we move him right up to the wall and stick him right on it, if we stick him even the smallest fraction of a floating point value to the other side of it, right, then he would not actually, that test would no longer succeed. So we don't have a very big margin for error there, and that's not a good thing, right? That's not a good thing at all, because that's just not how you want to roll, right? So there's a number of ways that we could deal with this, and it's unclear exactly necessarily what we want them to be. I'd have to think about this a little bit more to think about what I ultimately want to do. For right now, since we're only doing a very simple thing, I would say that the easiest thing to do is just for us to make sure that we put him a little bit back from the wall always if he hits the wall, right? Just make sure that you're a little bit back from it. That's probably the easiest thing to do, and wouldn't really cause any problems. But basically, yeah, this is something that we probably want to handle more robustly. Once we get forward enough that we've actually written collision detection the way that we want to do it with area shapes and so on, then we'll talk a little bit more about this case again and see if we can't do a cleaner job. But for right now, I'm going to do is make sure that he's back a little bit from it, right? So what I want to do there is say that whenever he hits a wall, right, whenever he actually hits a wall there, I would like him essentially to be just a bit back from it. So when he does that, I'm going to say that we're going to have this little, like, we're going to have some kind of an epsilon on the t. It'd be nice if that was in world space and not motion space, though, is the only thing. Because if I do it in the terms of the t value, then the problem with that is that's going to be proportional to how far he moved. I'll see if this works for now. Like I said, I don't want to necessarily do it quite this way when we get to the end, so I'm not going to sweat it too much making this quite right, because I'm not sure that we really care, but, you know, we'll see. So I'm going to make a little epsilon here, right? That epsilon is just typically a term we use for like a very small value that we're using to make a tolerance to work around floating point things. I'm just going to say that the t epsilon is going to be something like, you know, 0.01 or something like that. I don't know yet, but we'll just have some arbitrary value that we stick in there, and we'll basically say, okay, in the case where we actually hit the t min, what we're going to do is say we'll give it the minimum of that and that t result minus that epsilon distance, right? And again, this is not a particularly good way to handle this, I don't think, but I just want to see if this will fix our situation, right? Let's see here. Yeah. So you can see it's not really great, but, you know, and it is a little further away than I would like. You can see it's pretty far, actually, from where the guy is, if that makes sense. Yeah. So, all right. So we want that to be much smaller, maybe something like this. I don't know why I keep closing the application. So now we can go right up to the wall and hit it. I don't know why that was a little weird. I don't know why he's hitting it that way. That's very strange. I gotta take a look at why that's happening. Feels like his velocity is much larger than I would think, or his delta is much larger than I would think it would be. That is very strange. Yes, that's fine. Continue. Oh, that's right. We don't actually have a way to continue beyond that. So anyway.
So the minimum of 0 and t result minus t epsilon. And I suppose the issue here would have been that we're clipping past that tile, and that's why we were getting beyond this border here. But now, like, we get stuck kind of just before the edge, and that's why he made this smaller. And now maybe that looks a good deal better, perhaps. That does seem better to me. He kind of like stops, and then once we let go, the acceleration slows down enough once we stop holding down the arrow key to where it finds a smaller delta in that search. And maybe that's because we're just doing the one iteration, right? That might be the thing that he's missing. That he said that we need to do, but we basically only do one test to calculate T-min, right? Or wrong? I think that's right, because I don't see, like, we haven't bounded this. The bound that it has, just because it's one pass over this search, is 1. We're bounded to one iteration of trying to get the smallest possible, or I guess the biggest possible change in T that gets us as close as possible to the edge. So did just adding an epsilon fix the wall collision on y-axis? I think it works, but the thing is the origin of the player is at its feet, right? Yes. Yeah, that is what I am interpreting to have been the issue. And I mean, we can prove that if we set epsilon to be 0, right? But it sure seems to me like that was the issue. Like we just set this to be plain old 0. Well, maybe not. What was this before even? I mean, was this just T-min equals T result? I mean, I don't think I made any other changes before. Yeah. So something about the min value. We're still getting T result minus epsilon as the min. Would min give you back a negative if T result was negative? And therefore... Or maybe this is like a more precise 0. I don't know. I think that we could be getting into some floating point weirdness with this one. But anyway, yeah, that sure seems to be the fix, right? I mean, I guess that's why he added it. Because if we remove that, now we'll actually collide with that north wall. Yeah.
Yeah, I don't love that. Let's go ahead and take a look at this some more. Because that's not quite as good as I would have liked it to be, just in general. But anyway, that's what happens when he hits the wall. We now at least know when he hits the wall, and we just have we don't have a very robust algorithm right now in terms of dealing with what happens when we actually want the floating point stuff to work out properly.
Yeah, like you just said, we don't know how to get the floating point-ness to floating point the way we want it to. So yeah.
Oh, you know what we forgot to do though? I know what we forgot to do. We need to do our recanonicalize. That's something that we need to actually go look at as well pretty soon here, because that's going to get annoying.
Did he move that code that time, actually?
I know what we forgot to do. We need to do our recanonicalize.
Yeah, so he just does it again. Does it once to get the new player P to do the search and T off of, and then again after we've actually got the T-min that we want to use. And
that's something that we need to actually go.
he can't... He has to do it before updating the entity's position, doesn't he? He added it in down here, but that's pointless. We don't use the new player P after this point. Not really seeing a difference there.
Go look at as well pretty soon here, because that's going to get annoying real fast, since we haven't gotten to that point yet.
Probably because you get a negative result or something for T result. Yeah, well, yeah, exactly. But in that case, I guess I still don't understand why. Because even if this was negative, right? If T result is negative, it just gets more negative by subtracting the epsilon. And so either way, this would still be the result. Like, the point of this is that we're gonna choose this as the min. Like, will min return the value that's closer to 0, or will it return the most negative value, right? I don't know. I don't want to get too hung up on that, but obviously that's fixing our problem on some level.
Yeah. So I believe we won't hit that assertion now that we don't do, that we're doing a recanonicalize, but we still just have that nasty. I feel like that should stop right at the edge, and it isn't. So I wonder if I have another bug. I feel like I must have another bug there. That just feels really wrong to me. So I think there's a bug. I don't know why. Why do I keep closing the app? I'm used to today. I was working on stuff all day that did not have dynamic reloading because I'm working on some lower level stuff, and so I'm used to having to close the app every time I'm going to rerun it. So I feel like...
Dude, help me out here. New player P, there's no point in recanonicalizing this after we've assigned the entities, or after we've updated the entity's position. I think you just must not have caught that. Because this is the last reference to it. I'm just going to leave that the way it is, even though it's different from his code. Because I feel like I'm right.
There's something incorrect in what I'm doing that's causing me to get that stoppage in a way that I don't like. And so I'm going to take another look again here at this and say, what exactly is going on? Okay, that's fine. I typed minimum instead of maximum. Not the brightest move in the book. Yeah, so I was trying to clamp against 0 because I didn't want it to make it move backwards. And I typed minimum, which meant it was always going to pick 0. Oh, that's awful.
Well, that helps clear it up a little bit, right? Because why would we take the min? Basically, this would never resolve, but I still don't understand why that was helping prevent the... Like, even though it was not the thing that he meant to implement, doing that fixed this bug where we were clipping past the north wall. But now this actually does look much more right. Because, yeah, and then if we did get a negative result for T result, then we wouldn't be assigning T min to be that negative value. Okay, my confusion is cleared up. All I had to do was keep watching. That's almost always the case. Just let him work through it, and he clears it up, so I'm not confusing myself for no reason.
I don't know if that's Owlish name awful, but it's pretty dumb. There we go. That's much better.
What's worse, what he did or what I did? I had the answer. I just had to watch 2 more minutes, but he figured it out on his own. Like, that's the level of intuition I need to get to. I need to be like, and you know what? He probably even said it, so maybe I just missed what he said. But when he talked about using this T epsilon value, when he wrote in min here, and I just copied him like a dummy, like a fool, I should have been like, oh, I should have known. I should have trusted that. Oh, he wanted the max. Like, I need to get to that level of confidence with understanding what it is like we're actually trying to accomplish here.
Yeah. So now we're back to where I thought we should be, which is being able to hit exactly. I don't know why we're getting that. I wonder if I'm still not doing the recanonicalize properly. Let's take a look here. So tile.
Yes, he isn't. He isn't, because he's updating the player position before he recanonicalizes. I'm right. I'm right.
I might still not be doing that, but let me look at what tile rel is here. So tile relative is really large, so that seems wrong. So I think we're not doing that properly. New player P, we can localize position. So why are we getting that? What's the tile side in meters? Tile map, tile side in meters. It's 1.3. Well, no, that's about even though. That's pretty darn close, right? That's about right, I would say. So, yeah, that's probably close enough. These guys, yeah, these guys are just gonna have to. That's just the way that's gonna go, basically. Yeah, I don't think there's much of a way around that necessarily. Let's see here. I wonder if those should be loosened. Handmade tile. That's easy. So remember, we put these in just to check when we were doing recons. We know that they're not going to be exact at the moment. So I'm wondering what's happening here when we do this offset and we subtract after we do the divide. I'm wondering if it's why it's unable to get us to half properly like that. Let's see here. You know,
if I'm not right about this, I'll be very sad. But like, oh man, I hope that he finds it and it's not, you know, deep in the butt end of the Q&A or something.
Should I allow some slot there? Yeah. We'll see. All right. Because yeah, I don't know exactly what we want to do about that, but I don't love having those kind of. I don't like any kind of epsilon things really. So usually once we have an epsilon in the code, I usually kind of think of it as something that I want to go back and fix, but only once I actually know that I'm going to use the code. So like that looked like he went a little bit too far into there, which also looked a little bit janky. I want to see if I can reproduce that. I don't know if I can though. Yeah. So how did he get in there? I'm assuming that that is us not checking something the way that we should be checking, right? Because he shouldn't ever be able to move in like that, right? Like you can see, he can get through there, right? So how did he manage to do that? How did he sneak through that hole?
He's a wizard.
I would like to know. So yeah, you can see that. All right, so I think basically probably the easiest thing to do would just be to step up to the next level of collision detection rather than trying to get this to work more seamlessly, because most of the things that we're seeing here that are janky are things that will go away if we move to the next sort of level of goodness, if that makes sense. So let's just call that done for now, but observe the problems, right? The problems are we have to have an epsilon in order to not go through the wall. And even with that epsilon, I believe, and I can't say for sure because you know what we could do? We could actually do something to visualize this to make it a little easier to see what I think is happening there. And I just want to make sure everyone can see all the problems with it before we go up to the next thing. Let's see here. I want to render these guys a little smaller than they would otherwise be. So like that, I think. So there we go. So did you see that? Basically what happened there? That is exactly what I'm talking about. So I can't get through here, but if I could hit it directly at the edge, right? Where is it? Come on, there we go. Right, did you see that? If I hit it directly at the edge, I can get in between where I was hitting this wall and this wall, right? These two neighboring walls, the two vertical walls, I can just manage to get between it, right? And I think someone on the stream the other day was asking about how you can glitch through walls, and I sort of drew that case where the things were just a little bit off. So that's an example, right? Because numerically it's just not stable enough. So there's a gap, essentially, that you can sort of fit through there if you kind of work at it, right? So that's a good example. So, all right. So we've got a bunch of things that we would like to do now.
I don't know if I'm ever actually able to do this on my end, because I remember trying before when I was doing all this with Zig, and I just didn't have the finesse. I couldn't thread the needle. I couldn't find the 5 hole, and there's just no way for me to wiggle them in there. And that could just be because I'm not making this other change that he made, where he... What was that? It was rel tile or something. Oh no, was that in the tile code? I think it was. Rel tile. Man, where was that? It's an assertion, right? Yeah, right here. I'm not making this change, but I don't really know that that's actually what's going on here. But we'll see. It's like a less than or equal to being less than or vice versa. Yeah, I guess he did change that as well, didn't he? He changed the value he was comparing, and he removed the equals. But later on, he wanted to get rid of this. And I actually don't know if my code will trigger this because we're doing this all a little bit differently. We had a huge discussion about this way back when this code was first written. Not way back, but, you know, it was like 2 weeks ago. It was like the second or third week of me streaming all this business. But I never really see that assertion trip, the one that he keeps on running into. So I don't know if I actually need the equals here. But again, I'm not adding this like extra bit of slop into this comparison because, again, I think he's just got that recanonicalized call in the wrong spot. And that's the only reason he's got it down here, right? Instead of up here. And I think that's the only reason he's seeing... I can't speak for the assertion, I guess, but I think that's why he's seeing that weird behavior. Well, maybe... I guess maybe not, with being able to thread in between those tiles. There's a bunch of different stuff going on here. It's hard to pull it all apart.
So we've got a bunch of things that we would like to do now. And basically, what they boil down to, there's really two totally separate things that we want that both come from the same, that will both be solved by the same solution, if that makes sense. So what are they? All right. Oops, that's no good. Okay. So the first thing is that we are testing against an infinitely thin wall, right? We're testing against something that's like this little tiny thin wall, and all we know about is that pinpoint in space that the wall is. And what that means is that if the guy is on this side of the wall, he can hit it going this way. And if the guy's on this side of the wall, he can hit it going that way. But if he's right here or right here, right? Remember, imagine this was very, very microscopic. So he's just a hair on either side, right? He would still be able to move freely in that direction or freely in that direction, right? So if we're ever off by even the slightest bit numerically, and we thought we were stopping him right here, but we actually put him just on the other side, right? It'll allow the player to tunnel right through the wall. And that's a symptom of the fact that we're treating it as just this thin, right, this very infinitely thin wall. You know what I'm saying? So that's not very good. We don't like that. What we would rather be the case is we'd rather it be the case that this were a solid thing, right? Something that didn't have a very tiny, little, minuscule sort of thing to it where numerical imprecision could ever happen. We would want this to be as thick, you know, some thickness that allowed it to knock it through. And of course, if we think about it, the tile itself, right, is very much a solid thing. So like the fact that we were testing against each wall individually and treating it as infinitely thin isn't really necessary, because the thing that we're trying to simulate is not even an infinitely thin border around something, right? We're actually okay with just saying, hey, you know, you can't walk anywhere within this entire block, right? So what we'd like to do is solve this problem, first of all. But then we have another problem that we also have, right? And that problem is that our guy is too tiny in his collision sense right now, right? He can interpenetrate here because we're only doing collision detection with that point, right? And the reason that we're only doing collision detection with the point is because all we know how to do at this point is do collision detection along a ray, right? So we have a ray that he's moving along, and we're testing that against the wall, but really he should be some shape here, you know? He should be like a circle or something, so that when he moves when he's collision detecting against other things, it's actually whenever any part of the circle would touch the thing that he's colliding against that we'd stop him. And that would allow us to give him some volume, right? So that he stops away from the wall, like, you know, there properly, but also if he's going in the other direction, stops away from the wall, you know, like there or whatever, right? So something that gives him that volume back. And I think that's obviously something that we want as well. And so both of those things are basically sort of asking us to move up a level in complexity of how we're doing our collision detection and say, instead of talking just about lines, right? Because all we were talking about is lines. Basically what we wrote before was something that intersects the line of the player, right, with the line of the world, some kind of line in the world. So what we're talking about now is we're saying, let's move from lines to testing actual areas, right? Or volumes if they were in 3D, right? So let's go from lines to areas and figure out how to do area versus area so that we can actually have collision detection that is both numerically more robust because it's not talking about these infinitely thin things that are very easy to have epsilon issues around, A, and B, so that we can make the player have some volume as well, and so he will not be just a pinpoint that's moving around for the purposes of his collision detection. And so that's what we want to do. And ideally, we'd like to do that in a way that gives us a fair bit of flexibility with what these volumes actually are. You know, I would like to basically say maybe, at the very least, I'd probably say we might want to allow ellipses in there, right? Because I feel like the guy probably wants to be an ellipse. I don't know. Maybe he wants to be a circle. I don't know. It's kind of hard to say. it depends on what's going to feel good to move around, really, right? But I don't know if a circle makes some sense for him or if an ellipse makes more sense. The problem is, the perspective of the game is a little tilted in that sense, and so maybe it needs to be more of an ellipse to properly feel right in terms of when you're moving through stuff. But at the same time, that means that your motion is going to feel different depending on whether you're grinding against a vertical or a horizontal wall when you turn the edge and stuff. So I don't know, maybe it's a circle. So at the very least, a circle. At the very least, we need circles, because he's at least going to be probably a circle, because you want him to kind of be smooth and to be able to roll around things, so that when you're pushing into things, you don't want him to have you don't want his collision shape to have hard edges, because they'll get caught in stuff and be kind of janky to move around. So a circle's kind of nice because it rolls off things and it just feels nice and smooth to move around. So we definitely want circles, and then we probably also want rectangles, because there's probably going to be rectangle stuff in the game. But we might also want polygons, right? We might want to be able to say, let's be able to draw just arbitrary kind of little fancy sorts of things, perhaps, right? So that's another thing that we might want to have. And so we're going to want to basically think about, when we upgrade our collision here now, we're going to want to think about how we can do something more along these lines. So what we might do is just do circle and square, so we can do tile map. Well, we could even just do circles and circles. Let's do circle and square. Let's shoot for doing circle and square now. But to think about also polygons going forwards, because when we actually go to do the real shipping collision detector code, whenever we decide to do that, it'd be nice to potentially have those. I'm not sure if we'll want them, but we might. So we want to basically set our engine up, since that's we're still in the phase where we want to define all the things we need to do and get placeholder versions of all of them. I think that's basically what we're looking at. We're looking at circles, squares, and these. And maybe, I don't know if we want rounded rectangles as well. I don't know. We might rounded, things that are kind of rounded as well. I'm not sure. We will see. But circles and squares will probably be our target for now. So we'll try to do a circles and squares one, and then we'll go from there. I think that pretty much brings us to the end of the stream. It's a short stream a little bit today because we were chatting a little too much at the beginning. Everyone was gabbing. But that's a good place to stop anyway, because tomorrow we can write the new collision detector, and so that'll be kind of nice to have the explanation and the implementation in one day, or at least the start of the implementation in one day.
Well, I thought that we had, and maybe, I'm sure we still do, have to do the actual bounding on this collision detecting here, which we're not doing, but there's probably some other element to this that we're missing, like the transpose along the wall vector that we're colliding against, so that we can glide alongside it, I think is the reason why we're still sticking, right? We're not actually doing that, but we're also not getting as close as we possibly can before we start doing that, as best I can tell, because and maybe I'm just pulling this number out of my butt, right? I don't know if he actually mentioned that we would do 4 iterations, or maybe it's 10 iterations, something like that. But we just come in here and then we check along the XY coordinates of the tile we're trying to move into before checking if it's not empty. And maybe that bounded certainty actually happens here. I don't know. Actually, maybe it's here. You would go over 4 times, and then you'd keep calculating a new... well, actually, I don't know. It sure seems like we're only doing it... Well, no, that's not right, because we're searching all along. Yeah. No, I don't know. I think I'm I don't comprehend this nearly as well as I think I do. So I'm going to take some time to go over it. But one thing I do want to see in the Q&A is if somebody notifies him that he, in fact, recanonicalized in the wrong place. That looks like he also switches to the backboard, which is cool. No more flashbang. No more bright white light in my eyes, which is good. It looks like he just blackboards for the whole rest of the stream. So maybe he catches that in the next day, in tomorrow. And we'll see that. But it sure seems to me like this might be part of the reason why he's having that issue. right? Because it's in here. Well, I guess I don't know why that would trip the assert if you did this here or here. Maybe it's because it leaves the yeah. It wouldn't trip the assert this time when he calls it. And it steps in here and it does this. And I made this look like his code just so that I'm on the very same page as him. Because again, if I just have things slightly different from him, I know it'll somehow confuse me later on. But yeah, on this, you know, the first time that it recanonicalizes uselessly here, nothing bad happens, but it's when it comes back around and he does it again once we get the new player P to start doing the search and T, I think, that would then trip the assert, because the new player P that was assigned to the entity position on the last move player call, because it had not been recanonicalized, when you go to recanonicalize it again, there's some there it's using that old incorrect state, and we're getting a relative tile that is bad. So that's my hunch. Like, I'd have to actually go and verify that that's a thing that can. I mean, I guess I could just leave it like the way he has it and see if it trips. But again, I was never quite able to even do that. I never saw this. Well, actually, that's not true. I saw trip once, but it was not. It was back when it was originally written, and it was because I didn't have the equals, I think, on the upper bound, right? I think that's right. So yeah, I guess if what I'm thinking is correct, then I would expect this to trip. But just because it doesn't trip doesn't mean that it can't happen. And I guess that could be true with the implementation that I think is correct too. So yeah, I would have expected it to, if that was in fact the problem, I would have expected that to trip by now. So I don't know. What do I know? But we'll come back around to it tomorrow and see what the truth is. Devil just woke up. Well, you woke up just in time to say goodnight. Thanks for hanging out with me on another day of Odinmade Hero. We'll be back tomorrow to learn from Casey some more on how to debug canonical coordinates, and then hopefully I'll get an even more in-depth understanding of what it is going on with this assert that he's tripping. It's just it's like, on the one hand, yay, I'm not tripping that assert. On the other hand, it's like, is something else wrong? Because I feel like I should be tripping it. But at the end of the day, if you actually run the darn thing and run this guy all around the map, we don't have, first of all, we don't have that assert. Rather, we're not tripping that assert, and I can't get stuck in the wall here the way that he does. I guess that would be the thing to test really quick. Like, if this is messing him up the way that I think it is, or not even the way that I think it is, but if it's messing him up at all like I think it should be, it's got to create some bug somewhere. Anyway, whatever. Hopefully we'll get some clarity tomorrow, but until then, have a good rest of your night. I'll see you in the next stream.